Modern society relies on energy for survival. For most of the year, our classes discuss the generation and use of energy. Energy can be generated in many different ways, but the most common method currently is by burning fossil fuels and capturing the heat energy. One of our guests, Dr. Katz, spoke to us about global climate change. This is the change of global temperatures and weather patterns. And lately, the global temperature is increasing, which can affect various things from sea level to crop growth. Global climate change is being accelerated by the increase in atmospheric pollution. Of current energy generation methods, fossil fuels contribute the most to climate change and pollution. Then, Dr. Watson spoke to us about carbon sequestration, which is one method of reducing the pollution in the atmosphere. Carbon sequestration can be found in many forms. First, the carbon is captured from the atmosphere and then it must be stored. In order to store it, scientists could mix the carbon dioxide with ophiolites, which, through a chemical reaction, would remove the carbon and form a solid. Another method would be to place the captured carbon beneath the ocean floor in liquid form. At this depth, the carbon reaches a negative buoyancy zone, where the carbon sinks in water instead of rising. A third method, suggested by Dr. Chen, would be to genetically modify rubisco, the protein in plants responsible for converting carbon dioxide into glucose, to make the protein more efficient and viable as a carbon sequestration source. Another way to reduce pollution is to find alternative methods of energy generation. There are many methods of energy generation that emit little to no pollution, but in order to use these technologies, it must first be understood how electrical energy can be generated. We met with Dr. Dwyer, who spoke about early energy generation methods all the way up to current methods. Current generators work by spinning magnets around a coil of wire. Since the magnet is spinning, the magnetic field is constantly changing, which induces a current in the coil of wire. Current generators and turbines are machined to provide better precision. Dr. Ruff and Mr. Chapone both spoke to us about different methods used to design and manufacture products, which can be translated to generator and turbine production. Some of the current techniques are plastic injection molding, in which plastic is injected into a mold to form a solid plastic piece, metal molding, which uses heat to mold the metal pieces to the desired shape, and machining, which uses a computer-controlled lathe to cut away at the solid metal or plastic pieces. Although these methods are currently used and provide fairly efficient generators and turbines, new methods can be used to improve the efficiency of the generators. Jaron Cuppers spoke to us about advanced composite materials. These materials are much lighter and stronger, which can improve the efficiency of the turbines. Also, Jaron is designing a new process that can make the production of the composite materials faster and much less expensive. Also, occasionally, these generators and turbines may fail. When they fail more than they should, there may be a problem that needs to be diagnosed. The difficulty is that the turbines and generators operate at speeds too high for the human eye or a conventional camera to see. When this happens, videography specialists, such as Mr. Denner, are brought in. Mr. Denner uses high-speed cameras that utilize silicon sensors to create pixels that form an image thousands of times per second. These cameras can show the exact time when a generator fails and a video of why the failure occurred. Returning to energy generation. In modern electricity generation, fossil fuels are burned, which releases heat. The heat boils water to produce steam, which is used to turn turbines, running a generator to produce electrical energy. The problem is that this method produces large amounts of pollution, so new methods of running the generator need to be used. To talk to us about an alternative method was Mr. Scavello. Mr. Scavello is an employee at General Electric and has been working with wind energy for many years. A wind turbine has 3 long blades that capture the wind energy. Sensors in the nacelle, or the main compartment and body of the wind turbine, adjust the blades to maximize the efficiency of the wind energy capturing process. These blades are attached to a shaft, and as the blades turn the shaft from the captured wind energy, the generator is turned, creating electrical energy. Felipe Wichels also spoke about the wind turbines. He spoke of new technologies that allowed the blades on wind turbines to change angles depending on the wind speed in order to increase efficiency. He also covered technologies that would allow wind turbines to be directly incorporated into the power grid while controlling reactive power, making it easier to cut out the wind turbines if the wind speed is undesirable. Another way to run a generator is through the use of hydroenergy. Mr. Besha spoke to our class about hydroelectric power. Hydroelectric power is very efficient and reliable alternative technology. lasting much longer than any other generation source and using less space than wind or solar energy. There are many generation sites across the United States that have been operable for over 50 years. Hydroelectric energy uses energy from flowing water to turn turbine blades, which run the generator. Although hydroelectric energy is well developed, Dr. Dada estimates that the United States hydroelectric energy potential is only about 60% used, so there is more that can be done to improve hydroelectric energy. One method would be through using new generation plants that can be used directly in the water, reducing the environmental impacts on the surrounding areas. Another method is to use pumped storage. Pumped storage works by using excess generated energy at low demand times to pump water back above the generator. Then at high demand periods, that water can be reused to generate more electricity. A third option of energy generation is nuclear energy. Dr. Steiner spoke to our class about nuclear fission and the possibility of nuclear fusion. Nuclear fission is currently being utilized, but not very much. It works on the reaction between radioactive atoms, which produce heat that can then be utilized. Nuclear energy can provide a stable, consistent source of energy that can be easily controlled and does not vary based on external factors that cannot be controlled by human processes. An emerging technology for nuclear fission is breeder reactors. These reactors can recycle the fuel to be used multiple times, which reduces both cost and wastes. Another possibility is nuclear fusion. This technique is currently being developed and is of interest because nuclear fusion can theoretically produce 7 times more energy than nuclear fission. The only difficulty is that nuclear fusion requires extremely high temperatures, and all of the current methods of performing nuclear fission either take too long or require more energy than is produced. The other problem with nuclear energy is the radioactive waste that is produced. This spent nuclear fuel needs to be stored in a secure area where it would not be able to be repossessed by potential terrorists, and also in an area where it cannot harm the environment. Dr. Watson also spoke to our class about nuclear fuel storage. There have been many potential ideas, such as deep beneath the sea floor or in an area similar to Yucca Mountain. The only problem is that the locations are either too expensive to reach and use, or there is political and public opposition to the methods or the sites. The aforementioned generation techniques all rely on using various fuel sources to turn a turbine, which runs a generator to create electrical energy. But there is another way to generate electrical energy without using the conventional technique. This can happen through the use of semiconductors and photovoltaic cells. Mr. Colwell spoke to us about photovoltaic cells and the complex manufacturing process. Due to the delicate nature of the manufacturing of the solar cells, they must be produced in a clean room to prevent particles from landing on the cells. Mr. King from Rensselaer and Dr. Estathiadis from UAlbany spoke to us about clean rooms and their other uses. Clean rooms can vary in levels, going as low as or lower than a Class 1, which means that it has only 1 particle per cubic foot. These clean rooms can also be used for testing and research of new equipment, such as tools for processing on 450 mm wafers instead of 300 mm wafers, and for producing industrial products such as computer processors. Then we spoke to Mr. Fry about microscopy. The electron microscopes that are in the cleanroom can view objects at up to 300,000 times magnification, and can also perform functions such as E-beam PMMA, which can be used to imprint patterns on objects and may potentially increase the efficiency of solar cells. Photovoltaic cells work by having a positive side and a negative side, which are separated at a junction. When the photons from light strike the solar cell, they eject electrons from the negative side, which are directed through a wire and then to the positive side. After the cell is made, it has a low efficiency, around 5%, but through extra processes such as adding anti-reflective coatings and adding multiple junctions, scientists are starting to create solar cells with efficiencies of up to 40%. Dr. Borton also came in to speak to us about solar energy, but in a different sense. He spoke to us about passive solar energy, which utilizes the sun's energy for direct heat and light to reduce our energy consumption, instead of using it to create electrical energy. Passive solar can be utilized in many forms. The first is to angle the windows and roofs of buildings to allow sunlight and heat to enter during the winter, but not during the summer. This reduces heating and cooling costs. Another use is to place water pipe arrays on the roofs of buildings that capture heat and heat the water to reduce hot water costs. He also told us that enough solar energy reaches the United States per day to power the world, with more energy left over. Aside from photovoltaic cells, there is another promising method of generating energy without using a mechanically turned generator. This other method is fuel cells. Will Gathright and Micah Castile spoke to our class about polymer electrolyte membrane fuel cells, or PEM fuel cells. These fuel cells run on hydrogen at about 80 degrees Celsius, but there are other types of fuel cells that run at different temperatures with other fuels. In PEM fuel cells, the hydrogen atom runs through the anode, where it is split by a catalyst into an electron and a proton. The proton can pass through the membrane, but the electron must pass through an external circuit. When the proton and electron reach the cathode, where they are recombined using oxygen to form water. While in the external circuit, the energy from the electron can be used as electrical energy. After the energy from all these sources is generated, it must be transmitted and distributed to other places where it will be used. Mr. Nelson and Dr. Chow came to our class to speak about the power grid. Mr. Nelson spoke about the current transmission and distribution system, which is very inefficient. In the United States, we only use about 4% of the total energy produced. In order to solve our future problems with energy, we need to increase the amount of energy that makes it from generation to end use. Then Dr. Chow spoke about controlling this inefficient power grid and ways of increasing the efficiency. One step is to collect data on the voltage and current phasors, and then adjust the phasors using capacitors and inductors in order to increase the efficiency of the transmission and use of the power. Another step would be to introduce smart grids. Smart grids would allow power companies to discreetly turn off certain parts of appliances for short periods of time to reduce the load demand. This would be done so that people using the electricity never knew that it had been temporarily turned off, and on a large scale could still make a difference in the demand on the power grid. A third way to increase the efficiency of the power grid came from superpower. Currently, wires used for transmission and distribution cause about a 10% loss in power from resistance. Superpower is working on producing superconductors, a new technology that can transmit power with near zero resistance. This would result in a great increase in the efficiency of the power grid. Once the power has been transmitted and distributed, it must be used. Throughout the year, many guests have spoken to our class about various uses for electrical energy and how these uses could benefit society. Mr. Mielke came and spoke to our class about circuits. Without circuits, we would be unable to use the energy, since electricity needs a place to flow from and to. There are various components within circuits. Many circuits are either controlled digitally by a processor or through analog methods, which are what Mr. Mielke focused on. He spoke to us about controlling circuits through resistors, specialized chip packages that can perform different functions, and potentiometers, which can vary the resistance. Then Mr. Richter came and spoke to us about the future using electric vehicles. Currently, the United States uses over 20% of the world's oil, yet only produces 8%. Of this oil consumed, about 70% goes to transportation by using electric vehicles. This consumption can be reduced to nearly 0%, and the energy used for the electric vehicles could be produced by alternative energies that do not use fossil fuels. Electric vehicles are also useful because the motors can obtain efficiencies of around 90%, yet current gasoline-powered vehicles only have efficiencies of around 30%. This can greatly decrease the energy consumption of vehicles. Our third guest speaking about energy uses was Dr. Connors. His main focus was smart lighting. Smart lighting uses sensors such as occupancy sensors and pulse oximeter sensors to determine if a person is in the room. A digital processor can then control the lights, turning them off when people are not in the room, thus saving energy. In the future, Dr. Connors believes that sensors and processors will be able to precisely direct the light exactly to where a person needs it, saving energy and allowing people to have light wherever and whenever it is needed. Smart lighting is also about producing light more efficiently. Mr. Freering from Rensselaer's Lighting Research Center spoke to us about using light-emitting diodes for future lighting. LEDs use much less energy than incandescent or compact fluorescent light bulbs and also last much longer. The only difficulty is in getting the LED to dissipate heat so it does not burn out. Scientists are currently working on finding more efficient heat sinks for LEDs. With all of these innovations, we may be able to become independent of fossil fuels for energy and move towards a greener future. Throughout the year, our class has been learning about alternative energies and the use of energy, as well as many other developing fields. Our class has been given valuable information that will help us in the future and may also help us with our careers. For this, I would like to thank all of the guests who have spoken to our class this year.